properties of materials like brittleness, stiffness, hardness, fatigue, resilience, toughness, etc. Now we are going to see the property of materials. First, brittleness. Brittleness is the opposite of ductility. It is the property of breaking of a material with little permanent distortion. The materials having less than 5% elongation and the loading behavior are said to be brittle materials. In this image, you can see brittle material. Brittle materials with subjected to tensile loads snap off without giving any sensible elongation. Glass, cast iron, brass, and ceramics are considered as a brittle material. Thus, brittleness is the property of a material to snap off without giving any sensible elongation when subjected to tensile load. Then stiffness. Stiffness is defined as the ability of a material to resist deformation under stresses. The resistance of a material to elastic deformation or deflection is called stiffness or rigidity. In this image, you can see stiffness material. Material that suffers slight or very less deformation and the load has a high degree of stiffness or rigidity. For instant suspended beams of steel and aluminum may both be strong enough to carry the required load, but the aluminum beam will sag or deflect further, which means the steel beam is stiffer or more rigid than the aluminum beam. Now we are going to see hardness. Hardness is defined as the ability of a metal to cut another metal. A harder metal can always cut output impression to the softer metals due to its hardness. It is a very important properties of metals and has a wide variety of meanings. It embraces many different properties such as resistance to wear, resistance to indentation, resistance to scratches, resistance to deformation, and machine mobility, etc. Diamond is the hardest known material naturally. Now we are going to see creep. When a metal part is subjected to high constant stress at a high temperature for a longer period of time, it will undergo a slow and permanent deformation, which is known as creep. If the material will be continuously subjected to high stresses at higher temperature, crack can be formed, which may further propagate towards failure called pre-failure. Fatigue. Fatigue is the failure of a metal due to cyclic or repeated loading. The intensity of the load may be very less than the ultimate tensile stress, but due to the repeated or cyclic action of the load, the crack initiate and propagate, which leads to the fatigue failure. This image shows fatigue. The fatigue process leads to macroscopic and microscopic discontinuities, as well as component design features that cause stress concentration or common location. Resiliences. It is the amount of energy which a body can absorb without further deformation. This is the image you can see resilience. Toughness, the amount of energy that a material can absorb without breaking is called the toughness of the material. In other words, it is the ability of material to absorb energy and deform plastically without fracturing. Thank you.